Good day everyone, we are the Group 2 from BSCE 2G and we are going to discuss the procedures done in laboratory test number 1, which is the standard practice for reducing samples of aggregate to testing size and standard practice for sampling aggregates, and in laboratory test number 2, which is the standard practice for making and curing concrete test specimen in the laboratory. Before conducting the laboratory test, Dr. Vera took the time to deliver a comprehensive briefing to the class. Her goal was to ensure that each student had a solid understanding of how to handle and operate the intricate laboratory apparatuses with utmost precision and safety.
Okay? So suppose to be class, before na mag-inahin, ay before na magbuwan pa tanan ka, magkadapat ang mga tests.
Laboratory Test 1. These methods cover the reduction of field samples to the appropriate size for testing, employing techniques that are intended to minimize variations in measured characteristics between the test sample so selected and the field sample. The standard references for this test are ASTM C702 or C702M, Standard Practice for Reducing Sample of Aggregate to Testing Size, and the ASTM D75 or D75M, Standard Practice for Sampling Aggregates.
First method in this test was quartering. In this method, the apparatuses used were shovel and scoop. And the procedure is as follows. First, a sample of aggregate was obtained from 3 places in the stockpile. From the top third, at the midpoint, and from the bottom third of the volume of the pile. Second, the field sample was placed on a hard, clean, level surface where there was neither loss of material nor accidental addition of foreign material. Third, the material was thoroughly mixed by turning the entire sample 3 times. Fourth, the entire sample was shoveled into a conical pile. Fifth, the conical pile was carefully flattened to a uniform thickness and diameter by pressing down the apex with a shovel. Sixth, the flattened mass was divided into 4 equal quarters with a shovel. Seventh, 2 diagonally opposite quarters were removed, and the cleared spaces were brushed clean. Eighth, the remaining materials were mixed and quartered until the sample was reduced to the desired size. Ninth, the obtained sample was then transferred to clean trays in preparation for weighing.
The second method in this test was a mechanical splitter. In this method, the equipment used was a mechanical splitter. First, the original sample was placed in the hopper or pan and uniformly distributed from edge to edge, ensuring the sample appeared homogeneous, well blended. Second, the sample was carefully introduced into the chutes, allowing the aggregate to flow freely through the openings and into the catch pans. Third, this procedure was continued until the entire sample was halved, taking care to prevent catch pans from overflowing. Fourth, the catch pans were removed and set aside. One half of the material was further split. Fifth, the same procedure was followed, ensuring the entire increments were split until the desired test sample size was obtained. And the last one, the in-use material was retained until all desired tests were performed in case a retest was needed.
After the first laboratory test was completed, each material and sample was placed on a weighing balance to adjust the amount accordingly in order to meet the required quantity of materials needed for the next test. The apparatuses and equipments used were the weighing balance, trays, and vernier caliper. The materials were defined in coarse aggregates, cement, and water. Grease was also prepared for the next laboratory activity.
First, the weighing balance was clean. Next, the materials were prepared for weighing. The tray was then placed on the balance to tare it before weighing the materials. The fine aggregate was the first sample to be weighed. It was transferred to the third tray. The required amount of fine aggregates was 6.76 kilograms. As soon as the weight met the required amount of the sample, the material was set aside. The process was repeated for the remaining materials. The second sample weighed on this balance was the coarse aggregates. The required amount of coarse aggregates was 8.22 kilograms. The third material weighed on the balance was the cement. The required amount of cement was 2.94 kilograms. The last material weighed on the balance was the water. The required amount of water was 1.74 kilograms. The cylinder mold was also measured to determine the approximate volume of the concrete prism using a tape measure and caliper. Once measured, grease was applied both inside and outside the mold. This step would aid in the easy separation of the concrete prism from the mold.
Laboratory Test 2. This method provides standard requirements for making, curing, protecting, and transporting concrete test specimens under field conditions. The standard reference for this test is the ASTM C192, standard practice for making and curing concrete test specimens in the laboratory. The apparatuses used were the cylinder mold, shovel, and scoop. First, on a clear ground, the aggregates were poured and mixed without the addition of water until they were thoroughly blended. Second, the cement was added and the entire batch was mixed without the addition of water until the cement was uniformly distributed throughout the batch. Water was added, and the mass was mixed until the concrete became homogeneous in appearance and achieved the desired consistency.
The specimen was molded as closely as possible to the location where it was intended to be stored within the initial 24-hour period. The mold was positioned on a sturdy surface, ensuring it was devoid of vibrations and other sources of disturbance.
Number 1. The concrete was carefully placed into the molds using a scoop. Number 2. After placing the first layer of concrete, it was rodded using the rounded end of the rod, adhering to the specific number of strokes and rod size indicated in Table 2 of ASTM C192-88. Number 3. Upon rodding the layer, the outside of the mold was lightly tapped with a mallet around 10 to 15 times. Number 4. The same procedure was done for the next 2 layers. For each subsequent upper layer, the rod was allowed to penetrate about 12 mm into the layer beneath when the layer's depth was less than 100 mm. depth of the layer was 100 mm or more, the rod was permitted to penetrate approximately 25 mm into the underlying layer. Number 5. After consolidation, the surface of the concrete was struck off and it was then troweled to achieve a smooth finish. Number 6. After the finishing was done, the specimen was then labeled.
The concrete specimen was air dried in an open area. After air drying, the specimen was brought to the laboratory where it was left to dry for 24 hours. The specimen was taken out from the molds after a period of 24 plus minus 4 hours. The specimen was then placed in the water-filled curing box to begin the curing process.